We're looking at homework from section 2.4. This is question number 15. The number of courses taught per semester by a random sample of university professors are shown in the histogram. Make a frequency distribution of the data, then use the table to estimate the sample mean and the sample standard deviation of the data. So let's start by making a frequency distribution. We see the frequency numbers at the top of the bars of the histogram. So my frequency distribution is going to be a table where I list the different numbers of courses, which are 1, 2, 3, and 4, and then the number of professors who teach that many classes, which are 2, 17, 22, and 15. So that's my frequency distribution, which is the first question that was asked. The next thing that we're asked to do is to find the sample mean. So what we're going to do is apply this formula. The sample mean, x bar, is the sum of x times f divided by the sum of f. So let's go ahead and look at a table again, where we have our number of courses x and the frequency f, and then we're adding an extra column for x times f. So the distribution values that we just had in the first question are still valid here. But now in the last column, we're going to take the numbers from the first two columns and multiply them together. So 1 times 2 is 2, 2 times 17 is 34, 3 times 22 is 36, 4 times 15 is 60. So that is the table completed, but the formula calls for us to add the sum of the f's and the sum of the x times f's. So if I add the sum of the frequencies, I get 56. If I add the sum of the x times f's, I get 162. So the mean here is going to be 162 divided by 56, which is 2.89285 and so on. But we're asked to round to one decimal place, so this is 2.9. The next question is to find the sample standard deviation. So to find the sample standard deviation, we're going to build a bigger table. So we still have our x values and our frequency values, but now we need to find the x minus x bar values. Remember, x minus x bar is the deviation. So we're going to take each x value and subtract the mean value. So when the x value is 1, we get negative 1.9 because we're subtracting 2.9, which is what we found as our sample mean. 2 minus 2.9 is negative 0.9, 3 minus 2.9 is 0.1, and 4 minus 2.9 is 1.1. So once we have our x minus x bar values, our deviations, we square those. So negative 1.9 squared is 3.61, 0.9 squared is 0.81, 0.1 squared is 0.01, and 1.1 squared is 1.21. Then we're supposed to multiply each one of those times its frequency. So 2 times 3.61 is 7.22. 17 times 0.81 is 13.77. 22 times 0.01 is 0.22. And 15 times 1.21 is 18.15. Then we want to apply this formula. And the formula for the standard deviation is that s equals the square root of the sum of the x minus x bar squareds times f divided by lowercase n minus 1. So we need to add up the last column of our table because that's the numerator of our fraction. So when we add up the last column, we get 39.36, and little n is 56. How do we know that? Well, if we add all the values from our histogram, 2, 17, 22, and 15, then we get 56. That would be our sample size, but 56 minus 1 is where the 55 comes from. So then we plug this into our handy-dandy calculator, and we get 0.84595. Rounded to one decimal is 0.8. So that's our standard deviation, and that's your answer.